Welcome to a new test and teardown video. This time it's going to be the monster of the week. Holy crap. This one is very, very deep and it is insanely solid. It is 20 kilos, metric kilos heavy. Oh, that is heavy. For this size, I mean, it must be solid steel to be this heavy. It's a military receiver. AM and SSB is what it can do, and it can handle a frequency range from 980 kilohertz all the way to 30 megahertz. It's a manual tune like this with megahertz here and kilohertz here with super high resolution here, so that all this works super nice, and all the switches they go and all that. The only thing that I struggle with is that switch here, and I bet this one is the power on off because there is a special kind of feel and sound to this first click, and it says off here. It doesn't say power off, but how can you have an AKC that's, I don't know. I think there's no other on-off kind of thing, so that must be it, right? I didn't really know what this was, so I took some pictures and picture searched. And now I actually was able to find a type number. It's called Racal. Racal RA-1217. 1217. That is the model for this military receiver, and it should be from about 1965 to 1976. So that is more or less the age. I think we should look a little bit on the back, because it's also very special at the back. So here is the back. So I think we got some different outputs, some megahertz and some kilohertz and stuff like that. It's handwritten, the outputs here, right? And then there's a special military connector for whatever that is. We got some fuses, and that must be mains entry, again in a special main military connector. RF input in a BNC, so that's easy to access. I am actually very lucky to see this 240 volts, but I don't know what is what here, so I need to open this. There's no way I can power this up, or I can just measure here what's going on. Probably it's not a bad idea, really. Could be fun just to power it up and see if it blows up. But I also wanted to, I think it's better to take off the lid first. The first look in here is a little bit funny. There's a serial number on all the unit that says 932. Alright. And look at that. In the lid it also says 932 like that. I mean, that is a little bit special. I thought about those metal thingies here. They're just hanging in loose here, so there was probably something hanging here. Right? I thought I should unscrew these as well, but that was not the case. So I will have to deal with that in a second. Oh, even that is a heavy, solid steel plate. My goodness. That is a beautiful... Oh, that is a beautiful unit. Wow, look at that. BNC connectors for all sorts of alignments, handwritten, everything. Second mixer, third mixer, IF unit. Everything here is explained. What is what? So that will be the kilohertz section with a really good gearbox. Brass gears and all that kind of stuff that goes to the readout. And here is this switch that is not moving at all. And then here is another. This is the megahertz, and then there is another kind of gear here. This sounds a little bit funny. And then we hit some switches. Okay. Look at that, something hit some wires. This can't be the way it's supposed to be, right? Okay. RF attenuator, and then there's a little shielded. Oh, it's actually quite nice. Okay. And that is some sort of a pre-selector or band pre-selection thing that goes into all this RF unit antennas here, right? Yeah. Wow, but it's in a very, very nice and good, good state, right? I bet we got some really nice filters here. Some alignment holes, as you can see here. And then they are taped after alignment, and then that's it. Ooh, a lot of alignment screws. Here is a beautiful Canon connector with both RF and some signals. So 1 megacycles unit. So there's a reference oscillator you can take out. Huh. How beautiful. I think it's alright to try and power this up. Maybe I should just go in here and have a look, or I could also just try and measure those pins and see what happens, right? So I think I figured out exactly how this main entry is supposed to be, because I measure like 80-90 ohms between those two and 100 kilo ohms between those two to that one, and that one is also chassis, so it got to be like that. And see the fuses, they're hidden in oh yeah, thanks a lot, that's nice. Oops, gotta go. I am ready to do the first power on. I've already connected headphones, RF input, adjusted for 10 megahertz. This one is pre-selected to 10 megahertz. Off. I mean, let's just see what happens, right? I'm always a little bit scared about the first. That was so far so good. 14 watts. And what do you know? We got light in everything here. Look how beautiful that looks. Manual. Oh, look at that. Calibrate. So it's probably supposed to say something here in calibrate, right? Calibrate, tune, la 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 la. Yeah. Let's try and turn on. Oh! I hear something. Listen to that. I forgot to put on AM modulation. And here it is. So this is my 10 megahertz. I mean, yeah. Okay, we got a little bit of... Yeah. Okay. The damn thing works! how about we go and find an antenna? Oh, damn it. It's a little bit dark down here right now. Yeah, I'm okay. This damn thing took the fuses. Ah, man. Damn it, and all sorts of bad things to say. So there's a leak, but it took a few, 5-10 minutes I was playing with this thing. I was walking around finding antennas and loudspeakers and stuff. But I know there are some capacitors in the input section to chassis, and now they have leaked or something. Definitely. That's a little bit annoying, but this thing was working so well. But it took my HPFI, and again, I cannot repeat this loud and clear too many times. Always have your earthing connection. If you don't have this here, put a clamp on chassis to some earth. You need to protect yourself against leaks. It will give you a bad electrical shock, so you want your HPFI to switch off and protect you, exactly like what happened here for me. Yeah, okay, so it's, of course this is really, really nice military equipment, super easy to pull out the power supply, and there's of course a connector down here, and that is what we need to inspect and play around with a little bit. Let's see how we get in there. How are we going to do that? Yep, this lid first. So now we're inside this actually very beautiful and compact power supply. See, there's a 3055 transistor down there, and then there's a little PCB, Zener diodes, and a couple of transistors, and that's actually all there is to it. This whole unit uses about 13 watts before it took the HPFI. So if you look here, we got two capacitors to chassis on mains entry to the transformer unit, but it's not only a transformer unit, it's also, I think it also contains a bridge rectifier. It says something about that here, right? So all you have to do is give it some AC, and now out is your pulsed DC. Then you put your capacitors, and then you're done. So my mains entry, look at that, how they made this. Again, we got some capacitors to chassis, and then we got feed-through capacitors, inductors, and those feed-through capacitors. I mean, I can't remember those types of feed-throughs to fail, but this stuff can fail, and the capacitors here can fail. So I think I'm going to remove all those capacitors, including that 100K discharge resistor, that is to discharge the capacitors, and then I'll try again and see if it cracks my relay. I think I'll try without this, because I don't know if you can imagine, we had this kind of isolation rubber thingy. It's quite crusty and bad, and it was around this solder joint, and as you can see here, it's probably, what is that? Is that the leak to chassis? It's difficult to say, isn't it? But it's not as bad on the other one. I removed all those crusty isolations and also the components here. And I also removed the two capacitors down here. And now I'll just try one more time and see if it's running. If not, the leak can only be in the transformer, and then I am not happy. So yeah, this is always going to be interesting. So let's try without turning this on and see if there is a leak. You could also just leave it like this. Okay, let's try and turn it on. 13 watts. Let me try and just play a little bit. I will of course cut this video. So how long did it take before? I can't remember. I think I'm just gonna let it run for the next 10 minutes. It's going to be quite boring for you guys to see, so I'll stop the video. So I've been playing around with this for, I don't know, 25 minutes now, and it did not take my HPFI relay so far. I've been adding a few meters of wire to the antenna jack. I'm browsing around in the 7 megahertz range. See? You can hear some radio stations. That's actually quite amazing. I could even hear somebody talk Chinese and whatnot. Oh, I'm sorry, it's not called Chinese, but anyway. So definitely this receiver works. And okay, it needs a little bit of shiny and all that kind of stuff. It looks a little bit crusty, but it's also 50 years old or even more, right? The fun thing is about using your signal generator like this one is you can use the other channel to play back stored waveform memories. So isn't that a little bit funny? That is just crazy. Funny. Let's look a little bit inside the two oscillators. So this is the megahertz oscillator and this is the kilohertz oscillator. See? And it's actually really nicely made. This is the gearing for the readouts. I really like this stainless steel. What you see here on the outside, that is actually the click feeling, as you can hear here. That's each megahertz. And then it goes here. Can you imagine the mechanical interface of this when this is changing the oscillator frequency exactly 1 megahertz per click, and then the matching kilohertz oscillator here is still at the exact correct kilohertz setting, no matter what the megahertz setting is. I mean, this is no joke. This is definitely made by people who knows what they're doing. So this is the kilohertz oscillator, very beautifully made. And you're supposed to trim those with the lid on, of course, because there's a tiny little bit of interference from the lid down to the capacitor. And that's the same thing with the megahertz oscillator. You can go through the holes, as you see here in the lid. And then you can access the fine tuning here. So this is actually one of the IF filters. This one. Can you imagine a long chain of resonant circuits? Tiny little adjustments are made here to make this work, and they are in a socket, as you can see down here. So you can pull this unit out. Everything here is actually in sockets, and this is obviously normal for military equipment. If we look down here, down there where I'm pointing right now, if you look, you can actually see the end of this cannon connector. This is the second mixer, and there's actually a third mixer. This is almost identical to that one, and I had the idea this unit was a double conversion, but it's actually 3 IF path in this unit. And here is the main RF entry, and there is, oh, let me remove this. Then we got the pre-selectors. So here we got pre-selectors and amplifiers used for the first stage, and there is no mixing or anything. It just comes out here. The thing with this is that you select the different frequency ranges, and then you fine-tune a high Q resonant circuit in here for that particular band. And you can very, very easily hear this when you're receiving 8 to 16, okay, and then you fine-tune here for 10, for example, and then it goes very, very narrow band. The noise and the gain and everything goes up when you hit the right frequency band where you are. So this is a very, very interesting pre-selector, and it's also extremely good to handle very, very high power in band or near other frequencies. So you can imagine if you're working on a band very close to another band and somebody else is transmitting thousands of watts, of course you need a very, very good pre-selector like this one. Super smart way they've done this. And today it's not exactly done that smart, so it could probably outcompete per performance some new receivers just because of this front pre-selector system. Also, here's a bank of all the different IF filters, and this sets up the material bandwidth of whatever it is you're receiving, AM or SSB modes, and this is why you have so many different bands. Here's a band, or here's an available spot for another filter. You can see there's nothing in here, so this is of course the band that was dead. And here we got the band switch between the different filters, LSB, USB, AM, and then we got different width of filters, but we also got what happens here is actually it changes the cutoff, right? And then you can change the BFO that is used, of course, for SSB modes, right? And here you set the width of select actually the different filters, right? We got RF gain and we got volume. That's actually what it is. Very funny the way that this is done. But then you can of course optimize and handle or prevent distortion by overdriving. And the meter can show RF level or audio level. Yeah, I kind of really like this. It is just insanely heavy, and of course it's because this is solid steel. It looks a little bit like aluminium, but I think it is not really, because it's just insanely expensive or heavy. That's what I'm saying. This is 20 kilo. I don't know how the heck is that possible. Really, I don't see 20 kilo of steel here anywhere. So where is it? I mean, you could make this of what, solid mercury and still not even go there. So I don't understand this. Where is all this weight? Yeah, that is a little bit funny. All right, I think I will end this this video with this really interesting receiver. I hope you had a little bit fun, and see you soon again. I'll now have to put all this back here, put a little bit of marks so I don't swap those two, because I wanted to get this little shield box off. And here is, by the way, a 1 megahertz reference oscillator. I really like the way that everything here is made. Silk screening here is also very untraditional. Handwriting on this little test breakout. Very much military kind of style.